First question, a ray of light incident at an angle D on a refracting face of a prism emerges from the other face normally. If the angle of prism is 5 degree and the prism is made of a material of refractive index 1.5, then the angle of incidence is what you are supposed to find out. Now since we know the deviation delta is equals to mu minus 1 into A. Mu given in the question is 1.5 minus 1 and A given in the question is 5 degree. So from here the deviation comes out to be 2.5 degree. The angle of prism is 5 degree and the rays emerges from the refracting face of a prism normally. Then I2 and R2 both equals to 0. Now as we know, A is equals to R1 plus R2, but from here we know that R2 is equals to 0. So A is equals to R1, and if I put A value, that is 5 degree, which is given in the question, that is angle of prism, so R1 comes out to be 5 degree. But we know that I1 is equals to mu R1, which is equals to 3 upon 2 into 5, which is equals to 7.5 degree. And thus the correct answer, that is the angle of incidence, is 7.5. So correct answer for this question is option A. Looking towards the next question, a short pulse of white light is incident from air to glass slab at normal incidence. After traveling through the slab, the first color to emerge is. So as velocity of wave is given by the relation v is equals to f lambda, when light rays goes from one medium to other medium, the frequency of light remains unchanged. Hence, frequency is directly proportional to lambda, or greater the wavelength, greater the speed. The light of red color is of the highest wavelength and therefore of highest speed. Therefore, after traveling through the slab, the red color emerges first. So, red color is in option D. So, correct answer for this question is option D. Looking towards the next question, a passenger in an aeroplane shall never see a rainbow, may see a primary and a secondary rainbow as concentric circles, may see a primary and a secondary rainbow as concentric arcs, or shall never see a secondary rainbow. So as aeroplane is at the higher altitude, the passenger in an aeroplane may see a primary and a secondary rainbow like a concentric circles. So correct answer for this question is option B, that may see a primary and a secondary rainbow as concentric circles. Looking toward the next question, the radius of curvature of the curved surface of a Plano convex lens is. So, if the refractive index of a material of the lens be 1.5, it will be. So, first of all, we need to know the formula, that the relation between f, focal length, mu, refractive index, R1 and R2 is known as lensmaker's formula, and it is given as 1 upon f is equals to mu minus 1 the whole 1 upon R1 minus 1 upon R2. Now here given is R1 is infinity and R2 is minus R. So we get the formula while we substitute it over here as f is equals to R upon mu minus 1, where R given is 20 centimeter and mu given is 1.5. So on substituting these values over here, we get 20 upon 1.5 minus 1, which is equals to 40 centimeter. So as f is greater than 0 means a converging nature, therefore lens acts as a convex lens irrespective of the side on which the object lies. So correct answer for this question is option C, that act as a convex lens irrespective of the side on which the object lies. Looking towards the last question, the phenomena involved in the reflection of radio waves by ionosphere is similar to. So radio waves are reflected by a layer of atmosphere called ionosphere. So they can reach distant part of the earth. The reflection of radio waves by ionosphere is due to total internal reflection. It is the same as total internal reflection of light during light in the air during a mirage. That is, angle of incidence is greater than critical angle. Important point is to understand that the ionized part of the Earth's atmosphere is known as ionosphere, and ultraviolet light from the sun collides with atoms in this region, knocking electrons loose. This creates ions or atmosphere or atoms with missing electron. This is what gives the ionosphere its name, and it is a free electron that causes the reflection and absorption of radio waves. So correct answer for the given question is option B, that is total internal reflection of light in air during mirage. So correct answer is option B.